We have a problem here that says for us to find the volume of the solid obtained by rotating the region enclosed by x equals 8y, x equals y cubed, and y is greater than or equal to 0. We want to rotate this about the y-axis. So right now, we can see that things are expressed in terms of y. We have x is a function of y. So because of that, it might just be easier for us to choose the y-axis to be the horizontal axis and the x-axis to be the vertical one. So right now we have x equals 8y, which is just a straight line, if I can draw it straight, and x equals y cubed, which looks something like this, which intersects the line, at a point in the negative y and also at a point in the positive y. But all we care about is this region over here because y is greater than 0. So we want to find out where the line intersects the curve. So to do that, we're going to set the functions equal to each other. So y cubed is going to be equal to 8y, and we're going to rearrange the equation to solve for y. So if we factor out a y, we get y squared minus 8 equals 0. So we know from this that y has to be either equal to 0, positive root 8, or negative root 8. So the only ones that we are concerned about are 0 and positive root 8 because we know that y has to be greater than or equal to 0. So we're going to find or define our integral now. So the volume is going to be equal to pi times the integral from y equals 0 all the way to y equals root 8. So these are going to be our upper and lower bounds of integration. And we're going to have this area, which is the area obtained by taking the difference of the two functions, and we're going to rotate that around the y-axis. So let me just sketch the process of that again. So we have the area underneath this line. And if we rotate that around the x-axis, we're going to get something like this. We're going to get a cone. And it's going to be exactly a cone. So if we want to take the area underneath the cubic function, and if we want to shade that in, it's going to look something like this, and rotate it across or around the y-axis, we're going to get something like this. And it's going to be inside of the cone. So to find the volume of the solid obtained by rotating the region between the curves, which is this right over here, we just got to subtract the two volumes. So that's what we have to do. We have to subtract the two volumes. So to do that, we find out the volume of the first one, which is the function or the line function squared. So we're going to take 8y and we're going to square it. And we're going to subtract the volume of the second one, which is the cubic function squared. And this is going to be with respect to y. So now that we have this, all we have to do now is just compute this integral. So we can do that on a different page. So we have the volume is equal to pi times the integral from 0 to root 8 of 8y squared minus y cubed squared dy. So if we expand this, we get the integral of 64y squared minus y to the sixth. So right now, all we have to do is anti-differentiate, and we can do this by the fundamental theorem of calculus. So what we get is pi times 64 over 3 y 3 minus 1 over 7 y to the seventh, evaluated from root 8 to 0. So if we keep on simplifying, we get pi times 64 over 3, and we're going to do root 8 to the third minus 1 over 7 root 8 to the seventh, and minus 0. Well, if we plug in 0 for y, we get 0, so we just don't have to worry about that. And if we continue to simplify, we can, in fact, express this as 8 to the 3 over 2. So this is actually also the same thing as the square root of 8 cubed. So right now, if we want to simplify things further, we can actually write things in terms of powers of 2. So we can write 64 as 2 to the power of 6 over 3 times the square root of, well, 8 is just 2 to the power of 3, all to the power of 3. And same thing on the other side. So we can write this as the square root of 2 to the power of 3 to the power of 7. Simplifying further, we have 2 to the power of 6 over 3, and this is just going to give us 2 to the power of 9 minus 1 over 7 root 2 to the power of 21. So continuing on, we can factor out a 2 to the power of 4 from this square root. So we have 2 to the power of 4, and all we're left with is root 2 on this side. And here is the same thing, but we can factor out 2 to the power of 10. And over here, all we're left with is a square root. So we can actually bring the square root outside of these brackets. So we have 2, or we have pi times square root of 2, and these combine to form 2 to the 10 over 3 minus 2 to the 10 over 7. So if we find a lowest common denominator, we get pi times root 2, 7 times 2 to the 10, take away 3 times 2 to the 10, all over 21. And if we continue simplifying, we get pi times root 2, 4 times 10, or 2 to the 10, all over 21. And this 4 can actually can be expressed as 2 to the 2. So we have our final answer, pi times root 2, 2 to the 12 over 21.